Good evening, folks. This is Ron Tyler with the Emergency Management Associates.
The Earth is rotated around 3.5 miles southeast of the Earth now. The solar wind is also
Good morning, good afternoon, good evening, ladies and gentlemen, and everybody else around the world. Welcome to Emergency Management Associates, coming to you from the Area Command, 392 miles west of Kitty Hawk Beach, North Carolina. We want to welcome everybody to our program tonight. As we've been doing for quite some time, we're going to start off this program with a salute to the United States of America. We're going to have the Pledge of Allegiance and the United States National Anthem from the Barbershop Quartet Convention in 2015. Would everybody please rise?
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now would you make welcome, straight from Washington, D.C., the United States Army Corps Quartet.
Yeah.
Oh, say can you see by the dawn's early light what so proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars through the perilous fight o'er the ramparts we watched were so gallantly streaming, and the rocket's red glare, the bombs bursting in air, gave proof through the night that our flag was still there. Oh, say does that star-spangled banner yet wave o'er the land of the free?
America's finest. The United States Army Barbershop Quartet singing the national anthem at the Barbershop Quartet Convention in 2015. We want to thank these men who serve our nation so valiantly. We want to thank all our men and women in the United States Armed Forces that serve all over the world to protect every country and to also to protect the United States of America. We want to thank also our allied men and women in their armed forces who assist us in protecting them and also the world. God bless you. May you all return home to your families in safety when your tours of duty end. Thank you for your service, guys. We appreciate it. Folks, we have a lot to talk about, as we normally do. Yes, I'm about 50 minutes right now late from coming on the air, but I have a ton of things to talk about. I appreciate everybody who is joining us right now. I hope we have a lot more people that will join us coming on tonight. This is very important. I am addressing a lot of questions that all of you have had. I have gotten emails, I've gotten text messages over the last couple weeks about this information, and some of it even later than that, months ago. I've been researching it. I wanted to make sure I had the right information for all of you. But folks, what I'm going to talk about tonight is very important. I want to first talk about the pole shift. Everybody has been talking about the pole shift. A lot of people have not been addressing why the pole is shifting. A lot of people are not even addressing what is going on out in space and what is also going out or on inside our Earth. So tonight, that's exactly what I'm going to do. When we think about the Earth's magnetic field, okay, let's first talk about that. When we first think about the magnetic field, okay, I want to make sure I had the right graphic. When we first think about the Earth's magnetic field, we also associate it with compasses and navigation, but it's far more than that. Did you know that our planet's magnetic field has a rich history of change? Most people don't even equate that with what is happening now. Most people are so worried about a pole shift, but they don't understand why. Okay? So, let's talk about it. This also includes that pole shift that we've been talking about, switching of polarity, that spans millions of years. Some of you and I have been talking about this during the past 2 years. The Earth's magnetic field is generated by the motion of molten iron in its outer core. The field is not only providing us with our compass directions, but also leaves us with a permanent record in rocks as they solidify and or settle. The Earth's magnetism is a study. It's called paleomagnetism. It is a study of Earth's ancient magnetic field, and it's preserved in rocks, minerals, and sediments. It's based on the principle that certain magnetic minerals within these minerals record the direction and strength of the Earth's magnetic field at the time of their formation, the minerals formation. By analyzing these preserved records, scientists can reconstruct the movements of tectonic plates. They can study the Earth's magnetic field and the reversal events. A lot of people have been talking about the reversal events. We can also gain insights into past climates. And in our case, we can reconstruct the geologic histories of volcanoes. We talk a lot about volcanoes on this channel. We're going to talk about volcanoes tonight. Now, what we're talking about involves several different key components. One of them is magnetic polarity, which refers to the direction of the Earth's magnetic field at a particular location and a particular time as well. The Earth's magnetic field periodically flips, with the north and the south magnetic poles exchanging places. By analyzing the magnetism of rocks, the magnetization of rocks, scientists can determine the polarity of the Earth's magnetic field at the time that the rocks formed. Okay? I'm trying to give you some history here so you can understand what is going on. Another crucial component is magnetic inclination, which measures the angle between the magnetic field lines and the Earth's surface. The magnetic field lines in the Earth's surface is the inclination. It provides us with information about the latitude of the rock's formation. The latitude. By comparing the inclination of rocks from different locations and ages, scientists can reconstruct the movement of continents over time. Secular variation refers to gradual changes in the Earth's magnetic field over a duration shorter than those between polarity flips. Let me say that again. All these factors that I'm talking about now are what they're talking about in paleomagnetism, but that completely refers to the magnetic changes, the pole shifts. Okay? I hope you can understand it. The secular variation refers to gradual changes in the Earth's magnetic field over a duration shorter than those between polarity flips. Okay? These variations can be observed in the orientation and the intensity of the magnetic field. By examination of rocks of different ages, characteristics of the Earth's magnetic field come out. This information helps us in understanding the plate tectonics, and in Hawaii, it helps us to understand past periods of eruptive activity in the volcanoes. Paleomagnetism also aids us in dating rocks and archaeological artifacts. By comparing the magnetic signatures on rocks to known changes in the Earth's magnetic field and or data that they have obtained from lava flows, scientists can estimate their ages, the ages of the rock formations. Magnetic minerals that crystallize from molten magma. Okay? We're talking about magnetic minerals that crystallize from molten magma. Those things record the Earth's magnetic field direction. The magnetic minerals that crystallize from molten magma record the Earth's magnetic field direction at the time of their cooling. The cooling of the molten magma. Okay? By studying the magnetic properties preserved in lava flows and working closely with geologists, we can greatly improve our ability to reconstruct past geological events. Okay? Do you completely understand what we're talking about here? Everybody's been talking about the Earth's magnetic field and how there's holes in the magnetosphere and how the Earth is tipping 40% now. Okay? Nobody alive has ever witnessed it. Nobody that's alive today has gone through it. So we are presently going through this. Scientists are keeping an eye on our Earth. The tipping, the reversal, and the magnetic field. And the rock's magnetic field as the magma cools. So we know the direction of the magnetic field changes. Okay? We have a lot of things going on here. It's more than just, oh my gosh, we're going to die. Oh my gosh, what's going to happen? Nobody knows that. Nobody knows that. But scientists are taking all this data, and as things get closer and closer to pole shift, we're going to have more and more information about what's happening. What's happening, how it has happened, and where we may go after it flips. Nobody's been there before. But since the creation of this earth, yes, I believe in the creation of the earth, as it's talked about in the scriptures. Okay? Scientists believe that these minerals are millions of years old. Folks, those of us that live in the world of Christianity, it took 7 days to create the earth. In the scriptures, they talk about each day as being 1,000 years. Each day in the creation being 1,000 years. So that talks about 7,000 years. But all of these minerals have existed long before that. All these minerals, all these atoms, all of the things it took to create the earth have existed for millions and millions of years out in the universe. God collected everything together, didn't he? He pulled everything together to make the earth and the other planets. So these elements may be millions of years old. But since the time that these elements have gotten together as the earth, as a planet, it's only been like 7,000 years. Okay? That's what I want to point out tonight. Okay? We talk a lot about this planet. We talk a lot about earthquakes. A lot of us have a pretty good understanding now of why these earthquakes are hitting and where we're going to go with these earthquakes. We have looked at volcanoes, and I'm going to, in a few minutes, delve into these volcanoes and give you some history about the volcanoes and what's going on. Today, I'm talking about present day. Okay? So now you know where we're going. Okay? This is going to continue. This today is going to be the Emergency Management Associates Preparedness Day. Fridays are preparedness days. That's why I'm talking about all of this. I want to make sure everybody has a good handle on what we've been discussing. I think it's very important that everybody understands all of this before we get started. Okay? The first thing I want to talk about is Kilauea. Okay? Let's talk about Kilauea erupting. Okay? The last eruption of Kilauea occurred in the morning of June 7th. Okay? Kilauea has gone back and forth, erupting to not erupting. Today, Kilauea is not erupting, but the latest eruption started on June 7th. Now, for days to months leading up to all the eruptions at Kilauea since 2018, as well as Mauna Loa in 2022 last year. There's been increased earthquake activity and ground inflation. Okay? What's ground inflation? Ground inflation is when the magma that's coming into the volcano is increasing the height of the ground that the volcano sits on. In other words, the volcano is rising up. As it inflates, the ground rises up. Volcanic inflation. Okay? I want everybody to understand what is going on. I think it's very, very, very important. Not just with Kilauea, but all the other volcanoes that we talk about on this program. And what's going to happen. Okay? The increased earthquake activity that we see on the seismograms at these volcanoes, the activity indicates ground inflation. The volcano is increasing in size as the magma enters the magma chambers of these volcanoes. The magma storage system. The magma storage system below the volcano. In every case, with every volcano, when there's increased magma coming into the magma chamber, the magma storage system below the volcano become under stress. They undergo stress. A lot of pressure during and before the eruption. The magma coming into the volcano puts stress on that magmatic storage system below the volcano. The more magma you have, the more pressure is coming in there. The more pressure it has on the actual volcano system, the throat of the volcano, going up to the lava plug. We talked about the magma coming up inside the volcano and smashing against that lava plug just like this. The whole system goes under stress. Now, over in Hawaii, at Kilauea, and Mauna Loa, and Mauna Kea, and Halemaumau craters, Kilauea, and also, now I can't even remember the other volcano's name over on the kind of the northwestern side of the Big Island over there. But all these volcanoes around the world undergo those stresses as magma increasingly comes into these volcanoes. HBO scientists have noted these periods of increased unrest, and they closely monitor the data streams for signals that an eruption may be imminent. Now, we have talked specifically about this data not getting out to the people. No, they don't want us to know what's going on. Because if there was going to be an imminent eruption, they're only going to tell us within minutes or hours before the eruption. Because they don't want to panic anybody. They don't want to have people moving out of the areas. Okay? In the most recent cases, the signs of an imminent eruption become evident only about an hour before the eruption occurs. The clearest signals before these recent eruptions are rapid cooling. Yeah, cooling. And this earthquake activity occurs very rapidly. Those earthquakes occur very rapidly as the magma enters the magma chamber under pressure, causing rock fracturing, volcanic uplift. Most earthquakes before the eruption are not large enough to be felt. Minor earthquakes and tremors, as rocks beneath the surface are beginning to break, along with an increasing rate of inflation ground motion, upwards motion. Okay? Volcanic inflation, the rising up of the volcano area, the volcanic area. Okay? Ground motion, as the pressure in the volcano increases. The magma coming into the volcano is coming in under pressure, putting the storage system of magma that's down inside the volcano and under part of the volcano. Every volcano has a storage system. Okay? And as that increase of magma comes in, it's putting pressure, causing volcanic uplift, causing earthquakes to happen because rocks are fracturing inside the volcano. These signals indicate that magma is making a pathway towards the surface. Eventually, fountains of lava burst from the ground, and a conduit is established. In the case of that plug at the top of the volcano, the magma doesn't always force that plug out. The magma can come out of the side of the volcano, just like we saw at St. Helens in 1980. The weakest part of the earth. This can happen at the side of the volcano. We talked about having that magma plug and the magma coming up and hitting that plug, hitting it hard under pressure, and having that plug almost shatter, making fissures in that plug. And those fissures allow gases, hot gases and water vapor to come from the magma and go through those fissures. 6 to 7% of magma is water. So as that magma hits that plug of the volcano, it creates fissures, that pressure. The water vapor comes through those tiny fissures and it is hot. It's under pressure and it's hot. It also, because of the heat and the pressure of that water vapor, it increases the size of those fissures in the plug of that volcano. The larger the holes get because of the heat and the pressure of that vapor and the gases that are escaping, the likelihood for an eruption from the summit increases, because those holes increase and more fractures happen. The size of the holes increase because the water vapor and the gases escaping are hot. It's a physics lesson, and I've talked about this before. Okay? Eventually, the magma comes to the surface and can form fountains of lava bursting from the ground, bursting from the summit. When the magma conduit is established, the conduit could be straight up underneath the plug, forcing that plug to pop. It happens all the time. That's what we're seeing at Popocatépetl and Fuego and Shiveluch, for example, Kliuchevskoy, Sakurajima, every one of the volcanoes around the world. Okay? Wherever there's a weakness in that volcano, it could be at the summit, could be that volcanic plug, or it could come out the side. We see volcanic fields all around the world. where there's craters and vents that have happened when the magma has got a dike, has formed a dike in the crust of the volcano. Pressure of the magma forces that opening of that dike. Magma comes out of that, goes through that dike, and under pressure, if that area around the volcano, any side of the volcano is weak, it could force that magma out of the volcano. Okay? Fountains of lava burst. It could form, if it's at any part of the volcano, we can get fountains bursting or a huge lava protrusion, a huge pyroclastic explosion. And it can go miles into the air. We have seen eruptions recently up to 45,000 feet high. Just a couple of years ago, Shiveluch erupted up to 85,000 feet. Not with magma, but with ash and gases. The lava came out of the volcano, and it came running down the sides of Shiveluch volcano. Kilauea and other volcanoes, there's 5 of them over on the Kamchatka Peninsula that have erupted over the last 4 years that I know of. And like I said, we've talked about Aso volcano over in Japan, Sakurajima, Suizujima volcano, and also what's that one that just got through erupting the other day? Just south of oh gosh, it's one of those weird Japanese names that I can't pronounce anymore. Anyway, that volcano we talked about the other day. Okay? There's 61 volcanoes over in Japan. All over those islands of Japan. They even have an area to the south and east of Japan called the Volcanic Islands. All these islands that are formed around the world are caused by volcanism. So this happens all the time. It's happened millions of times during the Earth's formation process. We see that happening on moons of Jupiter and Venus. Even Mars at some point had magmatic eruptions. Lava bursting out of volcanoes on Mars. Okay? This happens. Now, as fountains of lava burst out of the ground, that conduit has been established. And there's a volcanic tremor signal that come out. And we've shown you the volcanic tremors when the volcano is erupting. Those volcanic tremors are a signal indicating fluid involvement. Fluid involvement, like the hum of water coming through a garden hose. It begins to replace the earthquakes. That harmonic tremor replaces the earthquakes, and it slowly becomes the dominant signal. Ground motion as the magma is leaving the volcano, ground motion begins to deflate. As that pressure is relieved by the eruption of the volcano, the pressures inside the volcano down underneath it decrease, and we get a ground deflation. The ground comes back down as lava is erupting from the volcano. Okay? This indicates the release of pressure within the magma system. Now, June 7th this year, I've got this picture of Kilauea up. June 7th this year, Kilauea erupted for the last time so far. Right now, Kilauea is not erupting. Now let's go back to the 2018 collapse of the Kilauea caldera. It left a pit. It left a pit in the volcano. Left a huge hole in the ground. That's not it. Okay, I'm sorry. Let me get this slide up that I want to show you. You're kidding me. It didn't come up. Darn it. Darn, darn, double darn. Just wait, just give me a second here, guys. Okay, I've got it. Okay. After Kilauea erupted, okay, all of a sudden the eruption ceased. There was a huge caldera, a huge lava plate, okay, up at the top near the rim of the volcano. It was lava that solidified. As the lava solidified after the previous eruption, it left a lava table. And after the eruption ceased, all of a sudden there was a small hole left in that caldera where the lava magma had been coming up and the lava had been coming out of that hole. When the magma ceased erupting, it continued back down into the ground. And many scientists wondered what happened to it, why there was no more magma underneath that caldera. A short time passed, and the caldera collapsed into the bottom of this crater that they call Halemaumau crater. Okay? All that rubble, all that rock, all that volcanic rock, that lava rock, fell down into the bottom of the crater. This is a good picture of what happened. Now this is a picture of the water that started to fill up the bottom of the crater. This is a picture of the water that started filling up the Halemaumau crater, Kilauea. Okay? But you can see what happened. You can actually see from the top of where these walls of the volcano were. You can see where the crater had been. And you can see the collapse that happened. Now, where that magma went, it went out into Leilani Estates and fern forest. That eruption there caused 24 fissures to open up in the ground. Fern forest and Leilani Estates. That eruption ended finally when the magmatic pressure down inside the volcanoes, down inside the lava tubes there on the Big Island, and the eruption stopped. Some of those cones and craters are now named volcanoes. Named volcanoes out in Leilani Estates and Fern Forest. Several of those cones also have active lava. Active lava down just beneath the cone. and scientists can see the red glowing lava there. Okay? That's what happened that led to that hole. The lava that had been there collapsed, went way down into the earth around the Big Island, and went out into what they call the East Rift Zone, RAFT zone, Rift Zone, went out into Fern Forest and Leilani Estates. Okay? That's what happened. Now, there has since been another eruption, but all this water that's in the bottom of the crater increased in size. A lot of water collected there. 700-foot lava, or excuse me, a 700-foot water lake came up into the crater. And what I'm going to show you tonight is what happened with that lava lake. Scientists decided to go and check it out. They wanted to ascertain what was actually, I'm sorry, this is the wrong picture. My bad. Sorry about that. This is from yesterday. The scientists decided to figure out what happened. Okay? And where that water came from. So a group of scientists, about 10 people, went down to the rim of the volcano, Kilauea volcano. They gathered there and they decided that they would have a drone with a tail down beneath the drone drop a container that would fill up with the water in the water lake of Kilauea volcano. They wanted to analyze it and figure out where that water come from. Whether it was groundwater that had seeped into the crater, or whether it was rainwater. Okay? So they devised this system, then they went down to the rim of the crater to put it together. That blue tarp there was to help protect the ground from the water, because scientists thought it might be very acidic, and they did not want to cause a chemical episode right there with the ground. So they put out a blue tarp. Also, to help protect themselves, they wore these big, huge aprons that were not meltable. You've seen welders use aprons. You've seen people that are manufacturing steel wear aprons that can withstand the heat of the molten steel. These guys are wearing aprons to protect them from the massive heat of that water sample that they were going to collect from Kilauea Lake. Okay? And this continued. Let me show you another picture here. Okay, again, they're going to go down into the lake with that drone. They hired drone pilots that have piloted drones over various national parks. These drone pilots that they had hired to do this project were not familiar with Kilauea. No one had actually launched a drone down into the depths of the Kilauea volcanic walls, down into the crater. Nobody had done that until this time. Okay? The sample bottle that they were lowering was attached to a cable underneath the drone. And so they went down into the crater of Kilauea, down to this water. Okay, I'm sorry, let me reduce this picture in size. I thought I'd already done this. I'm so sorry, guys. This is the water lake. Okay, this is a drone picture of that water lake inside Kilauea volcano. Okay, they needed to collect a sample of that water, and they later found out that it was rainwater. It was rainwater. The scientists had wondered whether the water of this lake had collected sulfur dioxide, which are those fumes, those cloudy fog areas around this lake, SO2. Yes, what happened, and it was also heat from the water, creating these steam clouds on the top of the lake. Indeed, there was magma down beneath that. There was a lot of magma down beneath that was creating that heat in the water. Now, they believed that this water contained SO2 and other acids that might be highly toxic. So again, they protected themselves, and I showed you that slide. The bottle that they had was about 3 feet long. It was made of polyurethane plastic that could withstand heat. And as they lowered that sample body down into the water, they lowered it down to within 10 feet below the surface of this lake. And as that water poured in to this sample bottle that they put up there, they dropped into the lake. As it filled with water, the top of it would finally close once that bottle was full. That sample tube had been filled. So the tube would not be collecting any air on the way back up to the surface, so the sample would be completely void of any earth air that might taint that sample. Okay, this is a big deal. It had never been done before except on volcanoes on the mainland. Never been done before except on volcanoes on the mainland. Okay? This is a drone picture showing that bottle before it was lowered down into the lake. You can see the drone lifting it into the air. And then they went down into the lake like I showed you in that other picture. It continued. Their sample mission continued for a while. It took about an hour and a half. Okay? Apparently this was quite an undertaking. Okay? This, folks, is a picture of the sample. Okay? As it is being dropped down into the water. These flags that you see, there's also an orange one that you can't see in this particular shot. This green flag and the orange flag that was attached was going to allow the pilot of the drone to ascertain how close that bag was to the water. Each of those flags was positioned within 5 feet of each other. That bottom orange flag is wrapped around the cord. Actually, you see 2 of them is wrapped around that cord just above the water sample bottle. So they would know exactly how close they were to the water, especially when they dropped that sample bottle down into the water. They hadn't quite gotten to that water level when this picture was taken. Okay? But they took that sample bottle. Okay? So now you get a clearer picture of what they did and how they did it. This is real fun, guys. I found it to be really interesting. I know those of you that are here, not all of you might be fascinated by what they did and how they did it. But in order to understand what happened there, what happened at Kilauea, they actually had to do this. They had to find out why that water had accumulated down there, and yes, they did find out. Okay? They did find out. This is the initial approach by the drone to the water. Okay? Oh, I'm sorry. Again, I thought I had all these pictures sized down. There it is. Okay? As that drone was lowering that sample bottle down into the water, it had to descend into the crater. And this is way down into the deep part of the crater, where that water was, that I just showed you where they dipped the sample bottle into that water. Okay? But what they found out is very fascinating. Okay? I'll be honest with you, it was very fascinating to me. And I hope it is to you. Because what we're going to talk about after that is other volcanoes. And this very well could be what could happen at any volcano. Scientists have done this at other volcanoes on mainland United States, but they've never done this at Kilauea or any of the other volcanoes on the Big Island or in Hawaii, period. This was the first. This was the very first. Now, they collected a total of 750 milliliters of water. They collected 750 milliliters of lake water. And some of that lake water they analyzed there at the lab that they have there near Kilauea. The majority of it they sent over to the main USGS lab over in California, in Menlo Park. And you guys know that I have had contact with those geologists and scientists at Menlo Park, at JPL. That's where I get most of my data from. But here they sent those sample bottles to Menlo Park to be analyzed. And they found out that the pH was normal. The pH was pretty much normal. Okay? Where was this acid? Where was this acid that they had anticipated having in the water? Scientists thought that the water had taken in particles of SO2. What they did find out is that SO2, sulfur dioxide that comes from magma, is diluted. It is absorbed into the water. And the water negates the SO2. The water makes the SO2 disappear. That was one of the most interesting facts that they found out from this. The water in that lake absorbed the SO2 and made the acid completely disappear. Okay? They found out all sorts of minerals that were in that water as well. Some of those minerals coming from the lava rock that had collapsed into that crater. What they knew when they got to the bottom of the crater at water level at that lake was that that lake was heating up. They took water samples and that water was very hot from the magma that was beneath the lake. Because the magma beneath the lake had heated up all that rock at the bottom of the crater. And that water came down from rain and groundwater that leached into the crater from rainwater. And that lake expanded up to 700 feet deep. Okay? That's what happened. Since then, one of the latest eruptions that happened in 2020 made that lake go away. Made that lake go away. What happened? When that magma came out of the volcano, it came out from the side of Kilauea. It came out of the side of Kilauea. They were not surprised by that. This has happened at other eruptions of volcanoes. But they thought for sure, because they knew that there was magma down beneath that lake, underneath all that rock, they were sure that was going to come up from there. It did not. It came down from the side of the volcano. It came down from the side of this volcano in two different locations. One from the southeast and one from the southwest. The magma came out of the side of the volcano and it hit that lava lake. The water was already hot from magma down beneath it. When that lava that came out of the side of the volcano hit that lava or that water lake, it dissipated and dissolved. It evaporated from the hot lava hitting the water. The water evaporated. Okay? Then after that, what do you think happened? Okay? The eruption continued. And it continued for quite some time. What do you think happened? I showed you the picture at the beginning of this presentation about Kilauea. The lava continued and it filled in upwards of the top or near the top of this volcano. And I don't know why this keeps happening. I'll make this picture smaller really quickly. Please excuse me for that. I had fixed this one time. I had this whole thing done up for this presentation tonight. I'm so sorry that this has happened again. Won't that sky just go away? Oh yes, we'll make it go away here. I'm getting to it, guys, I promise. Okay, I'm close. I'm very close. Now you see that lava lake. Okay? The lava erupted and erupted. Even the June 7th eruption, okay, helped bring this lava lake, this caldera, up to where it is now. Okay? Now, as of a few days ago, the eruption of Kilauea is over for now. Okay? It's over for now. The original eruption, like I said, and had the magma leave the Kilauea crater and go out into the eastern rim zone and filled in and made the fissures out in Fern Forest and Leilani Estates. It left that pit that I just showed you a few minutes ago. Okay? Incredible. And just so you know, an interesting fact. The bottom of the pit, the lowest portion of that pit, before that lake formed, the lowest portion of that pit was still 500 meters above sea level, 1,640 feet above sea level. The bottom of the Kilauea pit after the caldera collapsed. The pit was 1,640 feet, 500 meters above sea level. That shows you how tall that volcano is and how deep that pit was. During that latest eruption, the level rose to where it is now. Now, today I got notice from the Volcano Hawaii Observatory, or the Hawaii Volcanic Observatory, okay, at about 8:35 a.m., okay, on June 30th, today. Got notified that Kilauea is no longer erupting. The lava supply to the Haui Mau Mau crater, lava lake, ceased on June 19th. Based upon the lava lake levels and the behavior of the crater floor. Sulfur dioxide emissions have decreased to near pre-eruption background levels. According to the USGS Hawaii Volcanic Observatory, the lowering of the volcanic alert level for ground-based hazard from a volcanic watch which was what it was, as there were eruptive fountains in the crater there, to now advisory. The watch has now gone down to yellow advisory levels. Okay? It had been up to and including an orange level before. Now it's strictly at a yellow advisory level. Mauna Loa, which is west of there, Mauna Loa is not erupting. We've talked about this before. USGS said, or has said now, that the volcano alert level is normal. There's no advisory in place right now. However, that's not to say that there are earthquakes at Mauna Loa. We've shown you seismograms even last week that showed there's earthquakes at Mauna Loa, because Mauna Loa is recharging. Mauna Loa is recharging. Webcams, and you can go over to the Hawaii Volcanic Observatory and watch webcams that show no signs of molten lava activity at Mauna Loa. They say seismicity remains low. That's very interesting, because we showed you 2.5s and 3.0 earthquakes hitting Mauna Loa. But they say that is normal, that is low. Okay? But it is not uncommon following volcanic eruptions. It's not uncommon to have those earthquakes. The sulfur dioxide SO2 levels are background levels as well, just like Kilauea is right now. Let's go over to the Aleutian Islands now. Let's talk about the Aleutian Islands. Okay? Semi-Sopokanoi. Semi-Sopokanoi over in the southeastern part of the Aleutian Island, Alaska Peninsula. Semi-Sopokanoi has had an increase over the past week. There has been a steam plume that was observed when the webcam views became clear after the fog left the volcano. Clouds and fog formed over the volcano, and they've seen a steam plume rising from the summit of Semi-Sopokanoi. So they had a change to the current status. It's now at a watch level, aviation color code orange at Semi-Sopokanoi. Further west, Great Sitkin Volcano. It's also at a watch level, aviation color code orange, because there has been a slow eruption of lava that's continued over the past week. Small earthquakes detected a daily eruption at Great Sitkin Volcano. We've shown you some of the earthquakes at Great Sitkin and Semi-Sopokanoi. Now, we have talked about, and I'm going to go back to the USGS map here for a few minutes. I want to show you this. Okay? So if you guys would just give me a second while I set this up for you. Okay? We're going to go over here into Northern California. Before we get there, okay, we have had some earthquakes today. Over here on the Blanco fracture zone, BLANCO fracture zone. It's this line that goes from southeast to northwest here. Okay? That's a Blanco fracture zone. Yesterday there was a 3.5 earthquake out here, just off the coast of Oregon. A 3.5 earthquake. So the Cascadia subduction zone is still active. It's still active. We keep getting earthquakes here. Over here on the Gorda Escarpment, this is the earthquake fault that runs out westbound from Northern California coast, the Gorda Escarpment. Here on the Gorda Escarpment today we had a 2.9, 3.0 earthquake out here, west of the Triple Junction here. Just east of the Triple Junction on the San Andreas Fault, we had two other earthquakes here. This one is a 2.4. A 2.4 approximately 14 miles west of Petrolia, California. A 2.4 earthquake. This one here also on the San Andreas Fault earthquake zone. This is a 1.4. This is southeast of Petrolia. Okay? 12 miles southeast of Petrolia. Basically the same distance as this other earthquake is out to sea from Petrolia, California. This is 14 miles from Petrolia going west. This is southeast Petrolia going southeast, a 1.4 tremor. Okay? So we still see activity over here in the Cascadia earthquake range. Now, I'm going to go over here to Clear Lake. Okay? See these earthquakes here? This is in the Geysers. The Geysers. The Geysers is a geothermal area where we have had scientists that have drilled into the upper magma chambers of this lake called Clear Lake. They've drilled into these magma chambers of Clear Lake volcano to obtain steam, to pull up steam to power turbines to generate electricity for Pacific Gas and Electric and 4 other electrical electrical conglomerates here in the United States. Okay, we talked somewhat about that yesterday, and I showed you one of the set of turbines that is generating power there. This is Clear Lake volcano here. Okay, this is the volcano that they drilled into to obtain steam. So I want you to understand what we're talking about here. Clear Lake volcano is one of California's youngest volcanic areas. For many years, men have drilled into the upper magma chambers of this volcano to obtain steam to power turbines, like I said, to generate electricity for PG&E and other electrical conglomerates. USGS is studying this area to find out when this volcano will possibly erupt, and also what is going on inside this volcano. They have not done this study for a very long time. Since we've been having earthquakes here at Clear Lake, USGS has come over here and has decided that they're going to study Clear Lake and find out what is going on. And they're in the process of putting together an exploration video that we will at one time watch, probably by the end of the year. So they're studying what's going on at Clear Lake. It's still rumbling, not just down in the geysers. The reason we're having rumbling at the geysers is because seismic energy is searching out those man-made earthquake faults. Each of those drill points, each of the drill points down here in the geysers area, each one of these drill points is where seismic energy has hit the drill point, the great big hole in the earth that man has drilled into the earth, into the crust with. Seismic energy finds it and causes rock fracturing, earth movement. Earth movement. That's what's actually going on here. Okay? I wanted to make sure that everybody could understand what is actually happening here. Okay? Now I can't zoom into this area like I did on my tablet. But right here, just north of this facility here, is a drill point. There are tons of drill points all over this area. Tons of drill points all over this area. And every drill point, seismic energy hits that drill point, fracturing the rock, causing an earthquake. Right here you see one here today. This is 0.3 microquake. Okay? A 0.3 microquake here. And there's other earthquakes such as this one here. This is a 0.4 microquake. Further north, this is 0.1. A 0.1. This, for instance, is a 1.1 tremor. 0.1 to 0.9 are considered to be microquakes. 1.1 to 1.9 are considered to be tremors. 2.0 to 2.9 are considered to be minor earthquakes. 3.0 to 3.9 are considered to be small felt earthquakes. Felt earthquakes. This one is a 0.8 microquake. A lot of these are just microquakes, but occasionally we get a 2.0. This is a 2.2 here. This is a 2.2 minor earthquake. Okay? This one in red just happened. This is a 0.7 microquake there. So yes, we do get minor earthquakes, microquakes, and tremors throughout this area. And occasionally we even see a 3 or even a 4. Just a few weeks ago we saw a 4.0, I think it was a 4.0 hit here in the geysers. That does happen. that does happen. We've had a 4.5 there before. Okay, and over here at Clear Lake, we've even had some 3.4s and a 4.4 hit over here on the north side of the lake, right about in this area here. Okay, Clear Lake. And folks, this is a very real area. There are people that live here. Look at that. There's a good sized community here. Sue Ellen just gave us a $5 super chat. Thanks, Sue Ellen. God bless you for that. Thank you ever so much. We appreciate that. Lisa Lee is here. We're grateful to have Lisa Lee back here. I haven't seen Lisa Lee in a while here in our chat. Thank you, Lisa Lee, for being here. She says her grandfather is a sister from, my grandfather is a Slater from Rhode Island. That's cool. That's cool. But anyway, this is just one part of Clear Lake. Clear Lake spans this entire area. There's a city over here as well. Okay? It's all over. They have a boat ramp here as well. Okay? I've studied this entire area. It's incredible. It really is. I've been all over this area. I've even visited here a long, long time ago. Okay, see that area right there? Another city there. It's huge. And yes, when we have earthquakes here, they feel them. There's people living all over this area. And they have to be aware of what's going on. And I'm hoping that USGS will change their policies and start letting people know what is happening here at Clear Lake and other volcanoes. It would be very helpful for everybody to understand what is going on. Now, the San Andreas Fault starts up there just west of Patriotic, California. It comes all the way down the coast. Let me pull this here. See where it starts up here? It connects up with, in the triple junction, with the Cascadia subduction zone that runs all the way up to Queen Charlotte Island, Canada, British Columbia, Canada. Comes down here to connect with the Garlock, or not the Garlock, the Gorda Escarpment. Okay, it's called the triple junction. The San Andreas, the Cascadia subduction zone, and the Gorda Escarpment here. The San Andreas goes all the way down here. Okay, this earthquake just north of San Francisco Bay. This is Dillon Beach. We had a 4.0 here about a year and a half ago. We had another earthquake over here at San Anselmo. San Anselmo. Okay, I haven't seen this name in quite a while. That's why I butchered it. San Anselmo. Okay, this is just a 0.8 microquake. Over here, just southeast of San Francisco Bay, this is Sunol. S-U-N-O-L. Sunol, California. This is a 1.2 tremor. Over here, just east of Monterey Bay. Again, this is the San Andreas Fault. This is Hollister with a 1.9, 2.0 magnitude earthquake today. Over here on the Hayward Fault, this is Hollister, a 1.1 tremor. Over here alongside the San Andreas Fault, this is Tres Pinos. We have a 1.2 tremor here. 2 years ago we had a 5.2 earthquake. Caused a ruckus here. It tore a pipe over in the refinery here at Tres Pinos. Had a great big oil refinery there. It tore a hole in a pipe and caused massive fire here in Tres Pinos directly after the earthquake. Okay, so when I see an earthquake at Tres Pinos, I tell that story to let everybody know that that San Andreas Fault is dangerous all up and down this area. And one of these days I'll tell you a story that I found out about the 1989 earthquake there in San Francisco. I've told some people about what has happened there before, that massive earthquake. It was bigger than they originally said it was. USGS would have us believe there was a 6.9 earthquake. It was actually 30 times that. 30 times that. It turns out it was a 7.2 major earthquake that leveled San Francisco in 1989 at the beginning of the World Series. The Baseball World Series, October 1989. Okay? Then we go south. Okay? This is Tehachapi. Okay? You don't see any more earthquakes from that one I just showed you up here at Tres Pinos. San Andreas Fault goes all the way down here. It meets up with the Gorda Escarpment. It meets up with the Gorda Escarpment. Right here is a 1.2 tremor at Tehachapi, or should I say near Tehachapi. This is supposedly 10 miles south-southwest of Tehachapi. Okay? Further north and north of the Garlock here, because that earthquake was not on the San Andreas, it was on the Garlock Fault. This earthquake here just north of there is Bodefish. Bodefish is an area of California that's a huge volcanic area. It's a volcanic range. As you can see, there are craters, there are cones all over this area. This is a volcanic range, folks. This is a 0.9, 1.0 tremor. 0.9, 1.0 tremor. I can back it out. This time we come up to Ridgecrest. Ridgecrest area, okay? Right here, this is a 1.8. 9 miles east-northeast of Ridgecrest. Further north here is a 0.6. 9 miles northeast of Ridgecrest. This is a 0.8 in Cyril's Valley. Okay, all these seismic episodes happened just northeast of Ridgecrest. Northeast of Ridgecrest. Ridgecrest is a town right here. Okay? It's a pretty good sized town, guys. It's a pretty good sized town. Literally all over this area. All over the desert floor out here. Okay? So I want to show you that. Because yesterday there wasn't anything out here, but I think that was a lie. Okay? Let's go down into California, into Southern California. This is Castaic, California, 1.6 tremor here. Okay? Going further south, and notice there's 3 earthquakes in a line here. 3 earthquakes in a line. Guess what? The Newport-Inglewood Fault. The Newport-Inglewood Fault's here. Okay? 1.4 in Granada Hills. This one here is in Highland Park, a 1.0 tremor. East of there, we have, this is Wrightwood, California. This is a 0.2 microquake. And out here on the San Andreas Fault, here's another 0.8 near Parablossom, California. Both these earthquakes right next to the San Andreas Fault. Okay? We can go down the fault. Okay? Right here, this is Loma Linda. Loma Linda. This is just west of the fault. The San Andreas goes right into Loma Linda, as you can see, on the eastern edge of Loma Linda, California. It's where that wonderful medical center is. Okay? I like to show this. This is my One of the places I love to show, I've been here, Loma Linda Medical Center. Okay? Huge facility here. And yet we have an earthquake just on the western side of Loma Linda today. Okay? We continue westbound. This is another place that I'd like to show, because right before Ridgecrest happened, this entire area was filled with earthquakes and tremors. Hundreds of earthquakes and tremors throughout this area. This is Home Gardens, Glen Avon Home Gardens area. This, folks, they have labeled as another quarry blast. They have this labeled as a quarry blast. So we go in here and we look at the area. Folks, let's zoom in here. It's right next to a quarry. And that quarry is right next to a residential area. Okay? That quarry is right next to a residential area. And this blast, a quarry blast, allegedly happened a quarter of a mile deep. A quarter of a mile deep. Yes, this may have been a blast. Okay? Some of these blasts are not blasts. Some of them over a mile deep. They don't blast over a mile deep. We've also found that out. This one here, they labeled this a quarry blast here. Folks, this one is a 1.0 quarry blast. Okay? This is also a quarter of a mile deep. Let's zoom in here. Okay? Guess what? No quarry blast here. It's right next to a highway interchange. This is probably a football field length away from the highway interchange in that area. I don't think that's a quarry blast. There's no quarry anywhere near there. Okay? No quarry anywhere near there. Look at that. No quarry. Sorry, USGS, you lose. This is a 1.0 tremor, not a quarry blast. Nowhere near the quarry. Look at that. It's like 2 or 3 miles away from the quarry. That's not a quarry blast. It's right next to a highway interchange. Sorry, they don't do that. Okay? They do not have a quarry blast right next to a highway. Don Patoka says, a car backfired. Yeah. Linda Covington's asking, what are they mining? That area, guys, they mine sand and rock to build highways at. They have these open pit mines all over the place. They have rock that they mix with mortar and turn it into concrete, and they sell concrete all over this area. Okay? But I believe that's a rock and sand mine. Okay? They have those all over the place. Right? So no, it's not a quarry blast. Sometimes it is. And I've given credit when credit was due. But it was not that. Over here, this is west of the San Andreas. This is Cabazon. This is the Anza Gap. This area is the Anza Gap. We talked about earthquakes in this area before. The Anza Gap is a northern offshoot from the Anza Borrego Desert State Park. There's a California state park here, the Anza Borrego Desert Area State Park. Okay? This is another one. This is in the San Bernardino Mountains of Idlewild. Still part of the Anza Gap. These are earthquakes in Idlewild. And this one's labeled as 0.0, a surface quake. Folks, how do you have a surface quake? This is 6.3 miles deep. This is not a surface quake. That is 6.3 miles deep. It's not a surface quake. Right next to it is a 0.3 tremor. Again, this is 6 miles south of Idlewild. 6 miles south of Idlewild. Idlewild is a cool little town. I've been there. Now, I'm not sure if I'm going to be able to zoom into it because I don't really know where it is on this map. I found it once upon a time here. You have to drive along highways that are 2-lane blacktop highways to get in here. That might be it right there. It's just a small town. They have A-frame cabins you can stay in. A-frame cabins that you can stay in. Idlewild itself is a small town. They have great restaurants. I will tell you that right now. I spent a weekend there. They had great restaurants. They have shops all over Idlewild that you can visit. They're really cool to buy trinkets and stuff from Idlewild, California. Okay, so that's Idlewild here. Over here, this is the Anza area. Anza area again, the Anza Gap. This is also in the Anza Gap area, 0.4 microquake. And we go further in here to the Anza-Brego Desert area, and that's what we're at here. This is 0.5 microquake here. This is a 1.1 tremor. This is the Anza-Brego Desert State Park, guys. This is over in northeast San Diego County. At the top, literally at the top of the Chocolate Mountains. This is the top of the Chocolate Mountains. Now I can't go any further right now because USGS just shut me down here. So I will end this tour down here to the San Andreas Fault. I've showed this before. I want to make very clear that the San Andreas Fault is very active. That was my purpose here, right here. Does anybody have any questions on what we talked about tonight? I know we've gone very fast. We talked about the Hawaii volcanoes. We talked about the Clear Lake volcanoes. We've talked about Mammoth this week as well. Scientists are also going over to Mammoth after they clear from Clear Lake to look at Mammoth and see what exactly it's been doing. It's been having some 3.0, 4.0 earthquakes just as of the last week or so. So they're going to look at that as well. Hopefully we'll find out more about that as well. Any earthquakes? Richard Smith says Chocolate Mountains sounds yummy. The Chocolate Mountains, I don't know why they got their name except for the soil around there being brown. I can tell you that. The Chocolate Mountains are brown. Okay? There's a lot of sand up there. It's literally desert area. Okay, and it gets cold there in the winter. I've been up there. It's been freezing cold, and there's been sand, not just sand, but ice up there and snow. It's the top of the Chocolate Mountains. We're talking probably 5,000, 6,000 feet high. North of there, well, actually not north. West of there we have Palomar Mountain, which is 7,000, I think 7,600 feet high. That's where they have the telescope. Okay? But if you notice, if anyone's ever seen, many of you probably have seen the aerial footage from the original Top Gun movie. They flew over the Chocolate Mountains. Okay? A lot of the aerial dogfight footage is over the Chocolate Mountains and also over the Imperial Valley in California, over near El Centro Naval Air Station. Okay? Now, Kremlotz is talking about Terrell Croft. I've been friends with Terrell Croft and I've lost contact with him. He used to call me occasionally and I've been trying to call him and I can't get through to him. I've left him many voice messages. Terrell Croft has talked about, and Crimelets has talked about it here in the chat. He's talked about the black star, Nibiru. Okay? It's having a magnetic influence on our planet, allegedly. Okay? I'm not totally sold on that idea, how much of a magnetic influence it has on the Earth. But that's what Terrell Croft would explain to you. And those of you that have seen Terrell or been in his chat rooms here on YouTube, and he has been kicked off numerous times because of what he's talking about. YouTube doesn't like it. And I've had him on this show, I believe I had him on this show about 2 years ago. And Terrell Croft has wanted to come on. I've had it open. Terrell, if you're listening, you're welcome to come on this show almost anytime you want. And I'll put you on. I would love to see Terrell on this show, to have answered some of your questions, and also for me to interview him. He would be a fascinating person to talk to, and he already is. I've talked to him extensively about Nibiru, the brown dwarf, or the black star, whatever he wants to call it. Okay? The dwarf star, yeah. Okay? Cramlot says he lives close to me. He's a mega prepper. Yes, he is. You know, some people think I am. I've got 6 months worth of food. I told you a story when I lived out in Denver, about 7 or 10 miles away from where Carolyn lives, up there just outside of Denver. I lived southwest of that, southwest of Denver. And I've seen all sorts of stuff out there. Okay? One of my friends lived out there, moved out there from California, from LA. And I was invited out to their house one evening. In fact, it was the evening of December 31st, New Year's Eve. Their entire basement, guys, their entire basement was a food storage store. They had shelves, floor to ceiling, in their basement, full of canned goods and packaged goods. They had aisles through their basement whereby they could go down each shelf and pull whatever they need. They had their own store down there. And like I've told everybody here to do, when you use something, replace it the next time you go to the store, and maybe buy even one more thing that you might need, and put it in the back of the product that you already have on the shelf. That way you're using the old stuff that's still good and keeping the newer stuff in the back of it, so that you're always having good food to eat. Okay? Those friends of mine had a store in their basement. A lot of people do that when they can. Literally. My parents in Poway, California, had a shed that my dad had built out there that had all sorts of canned goods. Canned peaches, canned beans, canned everything. Okay? It was incredible what they had in there. Some of it had gone bad. After my parents died, we went over there, and some of it had gotten real bad. But anyway, that's that. Any other questions that you might have here? Okay? Tom Patoga's got a chat here that says, if yesterday was how you prepared for today, it will determine how well you endure tomorrow. And he's absolutely right. What you do yesterday and today is going to determine your tomorrow, and what you're going to have and what you're going to do. Okay? Rotation is key to food storage, Diana says, and she's right. Plan on doing that. Okay? Richard Smith is here saying, planning on brewing some crab apples this fall. Hard apple cider, bottle some. My parents had crab apple cider from out there in the mountains in Julian. They had crab apples and regular apples. They're beautiful apples, great big monster apples like this, and even smaller ones. That my mom made apple cider. She made apple cider vinegar. She made apple pie, apple sauce, all sorts of stuff. It was great. And don't forget a good can opener too, yeah. My mom did a lot of bottling, a lot of canning in bottles. Anyway, guys, if you guys don't have any more questions, I'm going to let you guys go. It's already 8:25 on a Friday night. Usually when we get here at 6 o'clock, which we didn't do, got here just about 6:30, we like to get out of here by 8 o'clock if we get in here by 6. 6:30 was tonight. We appreciate each and every one of you here. Guys, Friday night is our day that we have the weekend. Like I said, I declare if it's a good day on Friday, I declare it the weekend. Okay? I do. Anybody knows me, I declare it the weekend if it's a good day. Weekend so I can go out and play. Well, I used to do shows 7 days a week. I cut that back. If I do a show on a Saturday, that's usually my day off. Now if I do a show on Saturday, that's because something happened. Like I said, if I take tomorrow off, if anything happens between now and tomorrow, I will come back on the air and tell you about it. Okay? Right now we've only had some 5s, 4.9s, 5.0s, upwards of 5.4 earthquakes down in the southern Pacific. We even had a 4.5 in the north mid-Atlantic today along the mid-Atlantic fault, a 4.5. It's been a fairly quiet day seismically speaking. Yes, we've had a lot of 2s, we've had some 3s and some 4s, but most of it is just a handful of 5s around the planet. Okay, that's why I didn't go into a lot of earthquakes tonight. But that's what's happened. If anything else big happens, we'll tell you about it. I promise you, we're not going to let it go. Just not letting it go. On Sunday, we come on about 12 noon, sometime in there. Especially since I've had issues trying to get on the internet, trying to upload my software again. I've had to redo all my software here. Somebody doesn't like me, and that's okay. I'll work through it. So join me at 12 noon Sunday for Sunday school. I've been doing Sunday school broadcasts for about 2 or 3 years now. I thoroughly enjoy it. I was called in my church to be a gospel doctrine instructor, and I'm still doing it. I've been asked to continue it because it's not just people from my church that watch it. People around the world watch our Sunday school class. So I'm going to continue doing this. I get a thrill out of it. I get a lot of things out of it that even people don't even realize because I am the instructor. Our Sunday school classes, come follow me, the Savior said. So please join us on Sunday afternoon at noon, or Sunday morning at noon, depending on your philosophy of what noon is. But please join us there. We'd love to see you there. It's a wonderful opportunity for all of us to get together and talk about spiritual things. Okay? I want to share you a scripture that I found quite some time ago. And it still has a lot of meaning for me. Okay? I'm going over to 1 Timothy chapter 2. I want to start off with verse 6. It's talking about Jesus Christ, who gave himself a ransom for all, to be testified in due time. Whereto, and this is Paul talking to Timothy, whereunto I am ordained a preacher and an apostle of the Lord Jesus Christ. He says, I speak the truth in Christ and lie not. a teacher of the Gentiles in faith and verity. I will therefore that men pray everywhere, lifting up holy hands without wrath and doubting. Pray and lifting up hands without wrath or doubting. That's what I do. Okay? I teach the gospel of Jesus Christ. I have been teaching the gospel of Jesus Christ since the 70s. I would even say back into the late 60s when I was just a young man. Folks, the Savior makes me happy. I believe the Savior and his gospel can make each one of us happy in our hearts and in our lands all over the world. I love England. I have many of my relatives that came from Lincolnshire, England. I had a great majority of my relatives from Sweden, from a place called Örebro, Sweden. I love it. My ancestors came from Europe and Scandinavia, the majority from Sweden. Folks, I led a missionary life when I was in Sweden, visiting the land of my ancestors, and I even visited some long-distance cousins over in Sweden. The gospel is true all around the world. The gospel has meaning in our lives all around the world. The gospel of Jesus Christ can change lives all around the world. I ask the Lord to bless you wherever you're at, no matter what part of the world you're in. Whether you're down near Yuma or Phoenix or Tucson, Arizona, San Diego, California, over into the Geysers area, over into the mountains of Lassen and Shasta, up into Washington State, Alaska, Japan, Australia, Indonesia, anywhere in South America, Central America, Italy, Slovenia, Croatia. I wish you all a happy day. I hope you find Jesus Christ. I'm a teacher. I will continue teaching about the gospel of Christ until my last breath. Jesus Christ is my Savior and yours, our elder brother. He is the reason we live here. He brings happiness to all of us who live with him in mind. I know he lives. I love him. And someday, in the near future, I hope to kneel down at his feet and see the nail prints of his in his hands and his feet. And I will know no more then as I know now that he is Jesus Christ, the Son of the living God. I know that. And I love him. Jesus is the way, the truth, and the life. No man can come unto the Father but through him. May God bless you this day, that you may know who Jesus Christ is. God bless you that you could prepare so that you and your family will survive whatever happens here on this earth. Things happen every day. May God bless you and keep you. God be with you until we meet again. I look forward to seeing you shortly, within the next few days. God be with you, literally, until we meet again. Take care, everybody. Tell everybody about this program. Share it everywhere. Also check and keep sure and make sure your subscriptions are up to date. If you're not subscribed, please resubscribe. And then click on that bell icon and click on the word all to make sure you get notified when we come on the air. God bless you guys. I love you very much. We will see you around the corner. Good night, everybody. Much love.